Mais en fait, est-ce qu'ils ont eu quand même... But you saw the schedule, you knew that there's a class today. Yes. So the problem, yeah, you paid it just today.
Just at 1, yeah.
Yes. Just
Actually,
at 1?
At 1, yeah.
At 11? Okay. Ok. Après, peut-être on va se remettre en... Maintenant, oui, il faut que je le regarde. Yeah. Yeah, okay, just I will check. Okay, good. So see you later? Yeah. Good afternoon. Okay, just we wait a few minutes, and for the website, yeah, it will be arranged probably today. Okay, because no one said that there is a problem in connection, but it should be okay. Vous avez expliqué quelqu'un comment faire? Donc, on a fait de présence. So, just what you can do there, you can ask students to sign. Okay, and at the end, just to give it to me. Oui. Et après, il va y avoir un système biométrique. Là, ça va être... No, can you hear me? Online students, can you hear me? Yes? Okay, good. So we can start the class. Just remind me where we stopped last day. I think we stopped maybe here. Okay, so we said something about face analysis, but we will be talking about face analysis in depth later. Okay. So, do you remember in the first class we said that when you are interested in biometrics for security, there are two types of biometrics. There's something wrong. I don't know why I cannot write properly. I'm going to try to write. Yes. Okay, anyway. So, when you deal with security, in biometrics we can deal with physical features. And we can deal with what we call behavioral features. Sorry, I cannot write. Probably, maybe there's a problem in the board. Give me a few seconds, I check something. No. Okay. So I try to do my best. It's not that easy, but okay, good. So we have the physical features and behavioral features. Physical features is basically when you extract features from the face, from the hand, from the iris, from the ear, from the body. Okay, so you can use some sensors, you can use some cameras, you can use other sensors to capture data, physical data. Okay, and you have what we call behavioral features. It's a little bit different, and the idea is to analyze, for example, how someone walk. Okay, we can analyze walking. We can analyze how someone writes, so it will be regarded as behavioral biometrics. So this, the other one is physical, but this one is behavioral. What can you give as examples? Signatures. Okay, if we ask someone to sign, so we can analyze the signature and we extract some features. Always, when we say extracting features, it means we have to assign parameters alpha 1, alpha 2, alpha 3 to any information. So you have data, okay? You have data, and from your data you can extract parameters, and these parameters we call them features. So you can have one feature, 2, 3, or n features in general. Okay. So walking is a behavioral biometrics. Writing, signing, what else?
Keyboard typing.
Yeah, if you use a keyboard and you type a letter, you type any text. So if I give the same text to two different persons, probably the way they use the keyboard will be different. Do you agree with me? Okay, so keyboard or typing using the keyboard is regarded of one modality in behavioral biometrics. What else? Can you imagine just give me some ideas? Behavioral.
Online writing company.
So we said walking. We said writing. Signing. Okay, try to give me a list of behavioral information that can be regarded as behavioral biometrics.
Talking.
Talking, yes, talking. What else? Gestures? What else? Can I add eating? Yeah? Yes or no? I can add anything. In fact, I can add drinking. I can add, just tell me. Nitsa, you said tracking iris movement. Yeah, it may be possible, yeah. Uttara said speaking, voice. Can we consider this as behavioral? It depends from which point of view you use the voice. In fact, yeah, if you analyze directly the signal and, you know, because sometimes the voice can be classified from physical and sometimes from behavioral. So it depends, but we can consider this. Yeah, Bonta Naveen said dressing. What do you think? Yes. Yes. It may be also in information, the way you are dressed. What else? The height? No. This is physical because you extract something physical, you can measure it, you know? You can measure. And you say this is physical information. How many parameters I can extract when I'm interested in the height? Only one. Okay? And is it enough when you deal with just one parameter? Why? Because you can find many other people with the same parameter, the same height. Right? So that's why when you use only one parameter, you know, it's not enough to distinguish between persons. The more you increase parameters, the more you make the modality robust, you know, to distinguish between different people. Okay, so you understand walking, writing, signing, talking, dressing, eating, drinking. What else? We can imagine a lot of situations where we can analyze the behavior. Running, jumping, etc. Okay, good. So you see, in fact, the idea is that what you have to do in behavioral biometrics, you have to observe the person doing something. Okay, this person is doing something, and you try to analyze it as a signal, as an image, or something else. Okay, the person is doing something. The person is drinking, is walking, is signing. Okay, and we try to find a way to use the right sensor to access to some information. In terms of behavioral, here in the classroom, our classroom is like this. We have the main table, and we have, the central table, and we have tables like this. Okay, and we have students. Okay, when they enter to the classroom, so they take one seat. I don't know if you noticed, very often, and even I noticed, some students, they try to keep the same place, the same seat. Even if it's, the first time they came. Last time I noticed just one student, he entered in the classroom and he took this place. And after this, the day after, he came and he used exactly the same place. So even we can count the frequencies. Maybe one day he will change, but we don't know what is the motivation. But sometimes some people, they have some habits, Maybe they feel much more comfortable to stay here or here or here or here. And this is information, very important information that we can analyze. Okay? We can analyze using some digital tools. This is the idea. Imagine you have a camera here and you track people, and after this you have a kind of table and you say, this is the first day, Mr. Okay, let me I'll try to use a table like this. Maybe this is the first day, day 1, day 2, day 3, day 4, and each time for a given person, I will try to find which seat has been used. Okay? And maybe this chair will be number 1, number 2, 3, 4, 5, and so on. Okay? So what you can do, for example, day 1 he used the seat number 1. Day 2, 1, 1, and so on. And maybe after this it will be 2, or maybe 5, and so on. So we can, in fact, we can take this information and we can represent it as a signal. It may be something like this. What does it mean?
Some changes at the beginning, then...
Yeah, at the beginning he was hesitating, I don't know. Okay, and after this he said, okay, this will be my final place. And it's an information. And if you analyze the signal for someone else, you will find maybe something different. Okay? And it will be a signal. And you can analyze this signal. You can use all the tools, Fourier transform, wavelet transform, the DCT transform, anything. You can analyze, and you can use statistics. Do we agree? You can use statistics. You can use also some probabilities. It's about analyzing behavior of someone. You observe over time, of course. You will get signal, and once you have this signal, you will try to analyze it. So you can understand that this information, this signal, is not coming from, it's not extracted from the physical part, it's not from the human body. Because just you observe and you try to associate one signal to the behavior. And we can imagine lot of situations from which you can extract some signals like this. And it becomes for behavior. So once you have a signal, as I said, you can use some statistics. Why we can use statistics? What is the purpose? Assume we have a signal like this. We observed someone over 2 months, 3 months, I don't know. And after this we say, okay, let's use some statistics. So which kind of information we can extract? Yeah, someone who says sometimes user behavioral change. Okay. We use statistics to extract frequency. Which frequency? You can calculate, okay, the average. Okay. So if I calculate the average, what will be the information I will have?
This person usually or almost most of the time will stay in the state.
If I calculate just the average, I can maybe find the average here or here. Here is Hassan. Okay, what does it mean if the average is here? What does it mean? It means that this person likes to sit in this. Okay? Do we agree? The average is here. So if we find an average here, it will be the same. We will have an idea of this person that she likes this place, and so on. And we can calculate what we call, the histogram. You have already used this in image processing, but you can use it for anything else. So that's why it's important, when you can extract the histogram, you can even do it in MATLAB. You see, this scenario is just behavioral, and it becomes signal, it becomes image, it becomes mathematics, it becomes statistics, probability, and so on. So you can extract an histogram, and what will be the information if you have an histogram like this?
The horizontal line will be the seat, and the vertical line will be the number of many times.
Many times. So if, for example, sit number 6, I will find here 212. It means
Almost all day.
yeah, always he's using this sit, and we can see the peak here. Okay, it's information. If I compare the histogram of someone else, maybe I will find he has a peak somewhere else. Okay, something like this. At least we can see, we say, okay, this guy has this behavioral, and this guy has this behavioral. So it's an information. And if you see an histogram like this, oops, wait, I will try. If you have an histogram like this, what does it mean about the behavior?
Somebody every day changing this.
Yes, this guy, it means this guy, each time he's changing the sit, right? Do we agree? That's why it's very important to know how to transform any behavioral to a signal, and how to give meaning to the signal. Okay? And imagine now, because this is the histogram, you try to analyze the frequencies. But if you analyze, you go back to the temporal signal, and you have something like this, for example. Look, I will tell you something. This is person A, I call it A, and this is the person B. Oh my god, no, the pen is not, this is the person B. And this is the sit number 5, and this one 6. Okay, and we can analyze something like this. over time, we can understand that A and B, okay, are sitting one just close to the other one. And suddenly, you will notice the person changes, okay, and the other one keeps exactly the same thing. It's a behavioral. There's something happened.
They are not friends anymore.
Yeah, maybe they are not friends anymore. Something happened. So, you know, you can analyze just by signals. You say, it's a strange. I noticed there is this abrupt change here. But at the same time, what I noticed, for a person C, he was somewhere in place maybe 10, and suddenly he changed to 5, or maybe yeah, to 5. What does it mean? You have this signal like this, 5, it becomes 12, for example. At the beginning he was just a friend with 6, and the guy who was in 10,
A new friend of the day.
yeah, maybe a new friend. And here you start, you know, analyzing things, and you said, oh, what is going on? You know, because if you analyze one signal just alone, it's not enough. This is what I want to say. If you analyze just separately the signal,
Maybe not.
you will have an information, the fact that the person is moving. Okay? That's all. But if you try to analyze many signals at the same time, it's a kind, you will try to find a correlation between different signals. You may understand something. You may it's like decryption of specific situation.
This is what's called data mining. You have a bunch of data and you trying to mine specific information about. Yeah.
Sure, and methods like this can be even used
Social.
in marketing. We try to analyze your behavioral, and based on your behavioral, we try to send to you some advertisement. Yeah.
That's why Carrefour have a card that tracking my.
Yes, exactly. Yeah, this is a good example. So one student, he's showing the card of. Do you know? We call it Carrefour. Some countries we call it Carrefour. Yeah, it's like we are doing advertisement. Yeah. Okay. Anyway. So it's a big shop, okay, and you have a card, magnetic card, and each time you buy something with a code, they will ask you, do you have this card? So they will register exactly what you bought. I don't know, chocolate, anything. Okay, it will be recorded, and after this there will be some statistics. If they notice that each time you buy there, you take a few boxes of chocolates or something like this, maybe we can understand that you like chocolates, and you will receive in your email some promotional information to say, okay, now just for you, you can buy 10 chocolate boxes for just with discount of 50% or something like this. Maybe even for you, you notice sometimes you receive some emails and they said, oh my God, how they knew that I like this thing. And in fact, just what they did, they analyzed all the past information. It's done automatically, you know, and you can get this kind of advertisement. So you see, here, it's a kind of biometrics. We are analyzing the behavioral. The only thing that the purpose here is not for security. It's not for security. It's for marketing. But of course, we can analyze the behavior of some people for security purposes, for verification. Can you give me an example of behavioral for security?
The gate.
Gate?
I mean, how someone walking.
Yeah. For example, someone is walking, okay, so you will use a camera, you will capture, you know, an image.
Maybe I have a poor camera, it's not a very sophisticated camera that captures his face, or so it's enough to see how the way that he.
Of course, because in fact, if you want to analyze the behavior, the way he walks, you don't have to see his face exactly. You don't have to measure. You know what you have. Basically, you have to extract the shape of the body and the way he's walking, because if you are using a video, it will be a sequence, right? A sequence, so you will have many frames. So here we capture the first image. I think you will take some laps on this. You take the first image, you will extract some features. You extract the same the second frame, and you will have other features. So here alpha 1, alpha 2, alpha 3, and here it will be the same. And after this you will construct a signature, and the signature contains just values alpha 1, 2, 3, beta 1, beta 2, and so on, and you can use it as a signature. And if you are dealing with security, it means you want to recognize a person. And in fact, even for us, when we see a person, even if he is at 100 meters, sometimes it's like, oh, okay, this guy, he looks like this one. You don't need really to access to the details. You don't need to see his face. You don't need to see his eyes or something like that. But just globally, you analyze, our brain will analyze the way the person is walking, and you compare with the information in your memory, and you say, probably he looks like this guy. So here the behavioral analysis is for security, is to identify someone, okay, to recognize someone. But as I said in the previous one, it was for marketing. You know, just we analyze your behavioral, and after this there will be the purpose will be for marketing, and we can imagine many situations, you know, in different fields. Okay. So if I take another example like this one, look at this slide. We are still talking about behavioral characteristics or biometrics. So the person A is using a keyboard, okay, through the social network. And this person, we can imagine this person is discussing with another person. Of course, this one will not see this one. Okay? And we can imagine some applications to protect kids, because imagine this person is adult. He or she is more than 18. this person is a child, maybe 7 years old, and maybe this person will say, okay, my age is, I'm 6 or I'm 7, and he tries to chat with this person, and this one maybe thinks that she's talking with someone in the same range. Okay, so it may be a big problem, you know, here. That's why we can imagine a system to analyze the way the person is using the keyword. Okay, and we analyze many things. You can see here in this image what we can analyze. We can analyze the speed. We can analyze, you know, all the transitions between one letter to another one, and so on. And we can extract from this. We can extract a signal. Okay, you can extract a signal on the way you are using your keyboard. So we extract a signal from this guy, we can extract a signal from this guy. And there are some studies where the purpose is to estimate the age of a person based on the signal we analyze. There are currently some research works. Okay, and we try to estimate the age of the person. So what looks obvious for you? Do you think people will use the keyboard differently if you are old, if you are young, if you are... What do you think about this?
Okay, an old person use the keyboard softly, not fast than a child.
What do you mean by old?
Old, age.
Experience or his hand or people, for example, that can.
When you say old, when you say young, it doesn't make sense. Old. When I ask you to say what do you mean by old, you said someone who has experience. No.
Age.
Yeah, just you gave me just an idea about the age. 20, you consider 20 as old, you know? You see, just here, we don't agree. Just using this information, we don't agree. Because for you, old is...
I think she means older, not old. Older as comparison.
Maybe, yeah, you mean also adults or something like this. Or the thing which is important... when we deal with age estimation, something that's very important is to describe the ranges. And you can have some... Who use keyboards in general? Starting from which age we can use the keyboard for chatting?
No.
6? People at 6, they can chat?
They use.
I think for social media they ask maybe more than 16.
Whatever if they ask. Just I'm talking someone who is able to chat, to write.
These days, yes, maybe 10 or maybe 7.
7, 8? 8? Okay. So we can say, okay, 8. And you have to define some ranges. And you say maybe there is a range from 8 until maybe 12. And after this, from 12 until maybe 16. And after this, from 16 until even more. 20, 25. And after this, you have other ranges, 35 or 45. And we can continue. Maybe the last range will be 70 or 80. Okay, so I have a problem with my still. Excuse me. Oops. Okay, now it's okay now. Yeah, and another range from 80. So if you analyze people using the keyboard, can you just tell me what we can ask them to do to analyze the signal? Yes? To write the text. Yeah, to write the text. At the beginning you say, okay, let's consider this range. And before this, just if I ask you, do you think who will be faster in typing in the keyboard? I'm talking about 2016. I don't know, in the future, maybe it will be different. Just based on your own experience, between 16 and 45, yeah, faster. Okay? And we can imagine just after, the speed will go down. Okay? And we can imagine also the same here. We can imagine here people, they will type, maybe they, or even here, because at 16 they type quickly, I think, no? It depends on the person. But, you know, to have the right range, you need to do statistics, always. But anyway, at least we can have this idea, the fact that some people, they have a specific speed, you know, they use to write. Here maybe the speed is high and here is low. Maybe here it's low. What's the difference between this one and this one?
First one has no experience. He just
if I take two, for example, I take two persons typing at the same speed, can you distinguish between them? What can you do to distinguish between them?
It depends on the distribution of the location of the letters. Because younger people have problem with accessing like very far away letters. Other side, they don't have problem on accessing the letters, but they don't have experience. Okay,
so the fact our hands, you know.
I think by analyzing the paragraph, if it's correct.
This is a good thing. I was waiting for this answer, and this is good. Just for exactly, even Nitsa said the same, and this is what I was waiting for this answer. Okay, we can imagine even if two persons, you know, this is a small hand, it's for sure when you type in the keyboard you will have signal here, you will extract signal, and here it will be another signal. Okay, but at the same time we can analyze the information differently based on the orthograph and grammar, and you know, so you can use this parameter to distinguish between two persons. Okay, Uttaras, a difference can be made by vocabulary which in use. Yeah. Okay, so this is what we were talking about. So we can find a way to distinguish between persons. Okay, so as I said, the idea is to at the beginning is to define a kind of ranges, different ranges, and we have to analyze the signals. But for sure, if you want to analyze, if the purpose is to estimate the age of the person, you cannot deal only with one signal. It's not enough. What you have to do, you have to analyze a group of signals. So you have to create What?
Vector of
What you have to create? I said one signal is not enough. So you have to deal with, I try to write it even it's not, I try to write it. Can you imagine the future? Yeah, database. You have absolutely to deal with databases. Because you cannot decide just from analyzing one signal. Okay? You have to create a database. For example, if you consider ranges from 8 until 12, so, okay, you select kids within this range, and yeah, maybe you can take 100 or 150 to 100, whatever. And from this database, you can analyze different signals, and you can do some statistics. Okay? Because the parameters that you will extract will be statistical. Okay? It's not deterministic, it's just statistical, based on statistical analysis. So you observe 100 signals and you extract alpha 1, alpha 2, alpha 3, and alpha 4, and so on. And for each range, you can do the same. Okay? For each range, you can do the same. And after this, you will have a signature for each range. You will have a signature here, a signature here, and a signature here, and so on. So, what will be the next step? Once you have all the ranges, and you have extracted the features for each range, if you want to use the application for security purpose, what will be the next step?
extraction features from the query data and trying to fit it on one of those inlets.
So now, since you you have all the features, you have all the signatures, you have you will deal with an application. So someone is using a keyboard. Okay, he's typing. Okay, so you will not see the person. You cannot see the guy. But what you can analyze just the signal generated. Okay. So from this signal you can extract some features using exactly the same method as what you used here. Okay. So you extract the signature alpha 1, alpha 2, alpha 3, and so on. And what you can do, you can compare it to the signature coming from the range 1, and you compare it to the signature from the range 2, and so on. And you will try to take the one which is closer. If you find, for example, that this signature is close to this one, so you may say probably this guy or his age is within this range. Okay? Sometimes, and probably you will take some in the future, you will take some courses and even some labs about something which is very, very important, is classification. Classification. Methods of classification are very important, and you have in this Master 2, you have absolutely, you have to know how using the classification methods. There are many approaches of classification. What's classification? Classification, imagine here we have a black box. And for the black box, there will be as input some features that you extracted from an analysis, alpha 1, alpha 2, alpha 3, and so on. And what will be the output? Maybe range 1, range 2, or range 3, and so on. Okay? So there is an input vector, and this one is called the classifier. Okay? This one is classifier. You use an input vector, and there will be an output vector. So if, for example, these features are classified for the age 1 or range 1, so you will have as vector, can you tell me what will be the vector? 1, 0, 0, 0. It may be something like this. Okay? If you change the parameters, and the classifier should find in which range it should be. Okay, if it's range 2, so you will get the vector 0, 1, 0, 0, and so on. So the classification approaches are extremely important. And this year you have to deal with classification. You have to take labs, you have to practice, and you have to use this tool for your project, for example, if it's required. Okay? Why? Because classification methods, even after your master, if you take any project in industry, in research, very often you need to use these tools. And classification methods, you can find some toolboxes in MATLAB. But also you can find many other programming languages. Okay? So once again, classification is very important. And because you will see in a biometric scheme, very often at the end, to take a decision, you need to use a classifier. This tool, you can use something very simple, is to compare one-to-one. You have the extracted features, and you compare with the features in your database. And you take the one you achieved matching for this purpose. But sometimes your database is huge. Okay? If your database is huge, you have billions of features, you cannot compare one by one. It's too much. So it's much more interesting to use classifier methods. Okay? So you have to understand this. You can compare one by one. It's easier if you have just a small database. But if you have huge database, in such a case you have to use some developed advanced materials and tools. Okay? Do you have question? No question? Is it okay? Good. So, yeah, it was our example. As I said, there are many research teams working in this subject, but you can imagine other applications, of course. Yeah, this is what I was talking for. You know, I don't know if you saw this advertisement in the TV, in French TV. No? Have you ever seen this? No? And it was just you know, to say be careful when chatting with people. Maybe an adult, you know, this kid face maybe hide an adult face. So be careful when chatting in social networks. Okay? Because it's difficult, you know, to identify people, to say, okay, normally you are 42 years old, you don't have the right to talk with this kid who is 6 years old. Okay, the problem is that this person says, I am 7, okay, and he tries to talk with this kid. So that's why if we have some technologies to estimate the age of persons, at least we can say the system detected something wrong. It's close to an adult behavioral, and we can block, we can filter, we can use a kind of automatic filtering. Okay? And it's very important. So here it's about age estimation, and also we can think about gender estimation. Okay? And the idea is to say if this person is a man or woman. Gender estimation. Can we make the difference just by typing the keyboard? We don't know. You have to analyze the signals, because you can't say no, we don't think so, but maybe.
The same question with fingerprints. Yesterday I was reading a paper about gender estimation based on fingerprints, and it is possible.
It's what? It's possible, of course. It's possible to distinguish between genders just by using the fingerprint.
But when I first read it, I think, oh.
Yeah, at the beginning you say no, this is not possible, but really we can do it. Okay. So that's why it's very important, you know, at the beginning you cannot say this is possible, this is not possible. What you can do, you have to start a study, you have to use a database, and you have analyzed the results from a statistical point of view. And after this you can take decisions, or you can get some conclusions about the work. But if we say just directly yes or no, it doesn't make sense. You are now master's students, and in the future you will be maybe you will work in some industries, or maybe you will be in research labs. So it's very important. You cannot always say yes or no. If you say yes, people, they will ask you, give us the reference where you have seen this. And you have to say, yes, there is a study or one publication, something published by one research group, and this is the reference, so you can refer to this work because I saw it here. Or otherwise, if you didn't see it somewhere, you have to analyze it, to make some experiments, and to on database, and you have to use some statistical tools to say, based on the study I did, I think that it will be possible to distinguish between genders just using this or this signal. Okay? If it's something known, you will find it for sure in the literature. If it's something not known, you have to work on it, and you have to make some experiments, you have to make some statistical studies, and this is the right thing. Because, you know, it's very important, especially for research, never you can have some decision. You cannot take decisions, or you cannot get some conclusions based on the observation of just one signal, one image. It's not enough. If you say, just I analyzed one signal, and from this signal I can estimate the age, people, they would say, okay, let's try with another signal coming from another person, and we will see if it works or not. And here you can be surprised. So that's why databases are very, very important. And classification methods or approaches are very important. You can use them for biometrics for security, but you can use them for other applications, like, you know, in the medical field, or as we saw, for the marketing or something like this. Okay? Questions? No questions? Yes? Good. So now let's we are still, you know, in biometrics for security, and maybe some of you who were here in Master 1, probably you saw this slide, but since there are some new students, so it's important to remind you some what we call desirable characteristics of biometrics. Do you remember this slide? We saw it last year. It's not for performances, yeah, desirable characteristics of biometrics. When you, for example, you are asked to develop, how to say, a biometric application, you have to choose which modality. You can say, okay, let's work with fingerprint, face recognition, iris, or something like this. But the main question is how to choose between the different modalities. Which one is better? Yeah. So do you have an answer? If I ask you, what is the best biometric modality that one can use?
Purely depend on application.
It depends on the application. You know, it's very, very difficult to say this modality is the best one. We cannot reply, we cannot say which one is the best. Why? Because we have always differences between different modalities. So, to characterize a modality, it's important to analyze some characteristics. If, for example, you take face biometrics, how can we just analyze its performances, you know, regarding other modalities? For this reason, each time you select one biometric modality, you have to think about some specific characteristics. Okay? So the first one is the universality. What can you say about the universality of biometric modality?
anyone can have face.
Pardon?
Anyone can have the face.
Anyone has a face. Okay? So the idea is that is face universal? We can say yes, because all people have faces, right? If I take fingerprints, is fingerprint universal? Yes. Most of cases you have fingerprints. Of course, there are some special cases, people who have no hands or arms, or maybe they lost their fingers in an accident or something like that. For sure we can discard this category of people. But in general, if we say, okay, face, yeah, all people they have face, all people they have fingerprints, all people they have iris, ears, and something like this. That's why we can say, okay, this modality is universal, and this is the first condition. When you want to use biometric modality, you have just to answer this question: is it universal or not? Because if you propose a new modality, and maybe in some people, if it's not universal, they will tell you, okay, so maybe you can use it just for a small category of people, and this is not really a biometric modality. Okay? So the second one is uniqueness.
We talk about the height. We spoke about it's not unique for it. You could find many people in the same height. So it's not unique.
Yeah, when we propose a modality, as I said, we have to think about if it's universal or not, if it's unique or not. So is the face unique or not? Sure.
For twins, for twins,
Yeah, for
some similarities.
you can have some similarities for sure. Even you can find someone who looks like someone else, even if they are not brothers and sisters. You know, it's not something new. But the idea of uniqueness, at least in general, when you see someone, you see, yes, he's different than the other guy. Okay, for the fingerprint, you know, it's unique, even if you may have one probability of 1 over billions, I don't know, to find someone having the same probability, because we don't know exactly if it's really unique or not.
Again, it's the database problem, yeah?
The problem of databases and problems of, you know, we don't have all the fingerprints of people who died in the past. Imagine if we saved all the fingerprints of people who died few centuries ago. Here maybe we can analyze data and say, oh, I found a similar fingerprint. You have a fingerprint similar than someone who was in the 2nd century or something like this. So, but it's really impossible, you know, to do this. But we consider that it's unique because it's not that easy to find someone having exactly the same characteristics as yours. So, in terms of uniqueness, the idea is not to reach 100%. You know, in terms of uniqueness, it may be 99, it may be 50%, it may be 60. If we use as biometric just simple characteristics like the height, so, you know, or the weight. So you can find many persons. Can we say that the weight is unique? For sure, no. Even if I use this modality as biometric, I can use it, but for sure, I will find many other people having the same weight. Okay, so in terms of performances, it will decrease. But at the same time, it's something easy to use. You know, if your application is light, why not? In this classroom, maybe I can use it. I'm not sure if you have exactly the same weight. I will not ask you for your weight, but probably I can distinguish between you. If I measure the weight and the height, if I have two parameters, I'm quite sure, because database is too small. If the database is small, it will be easy to distinguish between people. But the more you increase the database, the more you make, you know, the application complex. Always think about databases. So when it's something very simple, why not? You can use one parameter or maybe two parameters. Okay? So we can imagine here in the classroom, even if you are just around 15, 10 or 15 or 20, it's not enough. And I can connect to my classroom just a device to get, you know, maybe the height and the weight, and just two parameters. And we can grant the access to people. For some people, at the beginning, you will enroll yourself, and your weight is I don't know, 70 kilograms, and your height is 2 meters. I don't know. So the vector will be alpha and beta, and it will be your signature. If someone else wants to use to access to the classroom, we will get the weight and the height. Maybe the weight will be the same, but there will be difference in the height. Okay? But if you use only one parameter, so here there will be some confusions for sure. So uniqueness, it's very important, and if you have, in terms of university, 100% for uniqueness, it's a good starter. Okay? Now, how about permanence?
Phase two, we
When you choose one biometric modality, sometimes you think about is it permanent or not? So, what can you say? One modality which is permanent. Okay. Is the face permanent?
yes.
Yes?
Kind of.
Are you sure? Yeah, Nita said that fingerprint is permanent. Okay? Okay. You have fingerprint. Someone who is, I don't know, 15, you compare it, you know, to the same finger when you will be 50, 75, it will be the same, permanent. Now, for the faces, it's not really permanent for many reasons. Yeah, Nita said for the Asian problem, you know, the same person, you can have, you know, different faces. This one is still kid. Okay. And over time, there will be the Asian, and here. Okay. So the face will change over time. Is not very stable due to the problem of the aging. But what else? Asian.
in accident,
Some disease. Okay, if we have some maybe injuries, but you know you can have the same problem here in fingerprints. You can have some injuries, and due to some disease, you can modify completely, you know, your fingerprint. But these are special cases. When we talk about accidents, when we talk about disease or something like, it's really special cases. I'm not talking about special cases, just natural cases, normal. Okay? So we have the aging. Aging is for sure. Something else. What makes the face changing?
if it is big or skinny.
The weight.
The weight.
The weight. Yeah. If this guy is doing a diet and he becomes like this, skinny. Okay. What else? Sunburn. Yeah. The sunburn. Only the color will change, but very often for face recognition we don't use the color. Yeah. Wrinkles. Okay. Yeah. Wrinkles here. You know, it's due to the aging. Okay. You will have wrinkles, but something else.
The plastic surgery is very.
Okay, plastic surgery. Okay, maybe this person will be, I don't know, like this. Okay, what else? Without plastic surgery. Look, I will write it. Expressions. Expressions.
Actually, he was saying if someone smiling or something.
Yes. And I can't write properly, but emotion. And emotion. So the same face, look, the same person, the same face, but if the expression is changing, so the information may change. Okay? So when you extract features, for example, this guy is 18, okay? And this one is the same, 18. Okay? He's doing some, you know, some expressions. If you extract alpha 1, alpha 2, alpha 3, it will be maybe different than alpha 1, alpha 2, and the other parameters extracted from the face. But it depends on the method you are using, because if in your face analysis, last time I said, if you extract just maybe some features from the eyes and you neglect, you know, some other regions, here the method will be very robust to the expressions. Even if you change the expression, parameters will not change. Okay? So it depends really on the method of features extraction. Okay. So, as we said, oops. So for the uniqueness and permanence, you know, some modalities change over time, some of them they don't change, and so on. So yeah, I had some propositions like iris. The iris, yeah, the same, is very stable. Is normally supposed to be permanent, except if we have some some disease or something like this. Okay. Something else. Yeah, of course we can say the same if we are using a hand. Is it permanent or not? It is supposed to be a little bit permanent, but you can have some variations over time. Okay. So, okay, another one, the collectability. What is it?
How cheap the sense of it?
How
Cheap the sense of it.
how cheap is?
How easy to collect?
I prefer how easy. How easy is to collect the information. So if you deal with face analysis, is it easy to capture or not? Capture the face. Yes? For face, what can we can say? We use. Look, you said very easy. Why you say this? Because we are in 2016. Okay? So imagine the same thing, the same question. I asked the question, I don't know, 4 years before, or even before. No, I wasn't here, but okay. But probably it wasn't that easy.
Fingerprint was easier.
Yes, and you know, so it depends. Now, using the camera, we can say it's very easy, and we can collect the data easy. Okay, fingerprint the same. Now we can find you know, fingerprint devices everywhere. You can even buy a fingerprint in internet, and the cost is very affordable, around 10 euros or something like this. You can buy a fingerprint. You can use it in your system. So the collectability characteristic is very important. It measures how easy we can use, we can collect the modality or collect the information using this modality. How about iris? Some of students are moving their heads, which means yes, so. Yeah. Maybe in the future, I ask the same question. Very easy. Iris is very easy. Okay. So at the beginning, you know, for iris we use some special devices equipped by cameras, but basically infrared cameras. But you know, now we can even capture the iris from a given distance. From 1 meter, 2 meters, we can capture the iris, and probably in the future we will be able to capture the iris easily. Okay? Good. Another one, the acceptability. What will be the acceptability? How about the acceptability of the modality? What does it mean?
Is it accepted on the society?
Yes. This is what we mean. When you propose a modality, make sure if it will be acceptable by the society or not. If you ask them to use fingerprint, some people now, okay, they know what is fingerprint and they can accept it. But in the past, it was a little bit different and difficult. Why? For the main reason is that fingerprints were used basically for criminals. If you say fingerprint, directly you think about criminals. That's why in the past, you know, this modality wasn't so acceptable. And I can say even now people, you know, they are afraid when they here fingerprint, they say, oh no, I don't want to give you my fingerprint, and I don't feel comfortable, and so on. So the acceptability depends on the depends on many parameters, you know, on the society, and maybe some modalities, maybe they may be acceptable in some countries and not in other countries. You have to understand this. Yeah, if you move to maybe India, now they are used, you know, all population, the population has been enrolled with fingerprints, palm print, and things like that. So for them, it's okay. They can use the fingerprint. But in other countries, I guess that probably they refuse, in some cases, to use such modalities for privacy, for many reasons. So the society is very important, and that's why when you propose a modality, you have to know what will be the application for which country, and how about the privacy, and so on. Okay, you cannot use the same modality for all people. Maybe some modalities are easy to use for kids, or maybe for young people, and difficult to use with old people. So you have to think about this, and collectability is very important. If we can collect the data easily, it's well, I'm talking about acceptability. Pardon. Collectability is when you collect the data using some devices, and acceptability is the fact that the society can accept or reject the idea to use some specific biometric modalities. Okay? And you have the last one, resistance to circumvention. So what you can say about this? Spoofability. I don't know if it exists, this term. Anti-spoofing system, yeah. It means, is it robust or not if we use face recognition, if we use fingerprint? Is it easy to spoof system using this modality or not? So this is the question. And it's very important when you choose one modality, you have to think about if it is very resistant or not to attacks. Okay, if it is robust to attacks. Okay, what will be the best modality is the best one if we have 100% here, 100% here, 100% here, here, and here, and here. This is the best modality. But unfortunately, it's impossible. Perfect doesn't exist. So to propose something very perfect, it doesn't exist. So that's why in the literature, what you can find, and very often you can find this even if you type in Google comparing modalities, you can find some tables like this. And in these tables, what you can find, you have here different modalities, for example, fingerprint. Sure. Fingerprint, face, blah blah, and so on. Okay, and here you will have, what can we write here? Tell me. So here we can write uniqueness. Uniqueness. Here we can use oops. So here We can use the, I don't know, acceptability. We can use collectability, and so on. All the characteristics that we are looking for. Okay? So here you can add characteristics, all characteristics 2, 3, 4, and so on. And after this, what you can find, these tables, you know, they may differ from one paper to another one, from one literature to another. Why? Because it's still changing over time. Fingerprint is unique, okay? And you say, okay, yes, regarding the uniqueness, you have 3 stars, for example. Okay? Maybe for face you will find 2 stars. Acceptability, maybe you will find 2 stars for acceptability. And for face, maybe you will find 3 or something like this. Okay? So it's this table is interesting to help you how selecting one modality among other modalities for specific application. So with a table like this, you can compare different modalities, especially for someone who is not used to these different methods. You can compare, and you can take a decision which one you have to select. This one or this one or this one. Why? Because you have a kind of rates. So if you have an application, maybe they can ask you, okay, we need just to set up biometric application to control something, to control access, and it's up to you to decide which one you want to use or you can propose. So you can say, okay, if I use face recognition, so I have all these features, these characteristics, and you can compare with fingerprint, with iris, and you have to add something which is called the cost, which is very important. Each time you develop an application, they will ask you, okay, how much? I agree with this, what you proposed, but how much it costs? And this point is very important. Okay, so you can use this table. As I said, you can find it in the literature. Maybe you can find some differences. You know why? Because each time, sometimes to judge one modality, it's a little bit subjective. It's not really objective. And if, for example, I propose this table in 2016, maybe in 2030 will be completely different. Okay? Just you have to know that it exists. Questions? No? We take just maybe a break, and after this we come back. So maybe 15 minutes, okay? I will write it. Okay, I'm back. So, okay, we finished this this part, and let's see now something else. Maybe yeah, the students coming from Master 1 already saw this similar slide. So here we'll be talking about biometric system mode. It means when we deal with biometrics for security, we have, in fact, we can use this biometrics in two modes. Okay, so in some applications we can be interested in using biometrics for verification purpose, or sometimes we call it authentication. And in some cases we can use it for what we call identification. And just you can notice something here. For authentication or verification, we use you know, one-to-one, okay, one-to-one. And here for identification, we use 1 to n. Okay. So what's the difference between verification and identification? Let's start with authentication or verification. 1 to 1. Is there someone who can just
When, for example, you have the password and you enter a correct password, so this is verification.
Yeah? Yeah, go ahead.
About identification, when
No, for verification, can you explain? Verification. Can you repeat? I didn't understand.
when you enter a password, for
Yeah.
example, and the password is correct, this is verification.
Mm-hmm.
Identification is related to database. When you have your features are similar to a database range, for example, you are identified.
Okay, but it's a long explanation. Okay, look, in verification, it should be clear, because always when you want to develop a biometric application, you will be asked if you want to use it, to use your application for verification or identification. Verification is very simple compared to identification. Why? Because verification in general, it basically consists in comparison. The user at the beginning should claim, we say claim his identity. In verification, you claim your identity. You will provide your identity before using the biometric system. For example, when you say, when I would like to say claim your identity, maybe you have to provide what, maybe, yes, you can provide username, sorry, just problem with the pen. Okay. So maybe you have to provide username and password. Okay. Sometimes you have to provide only your name. Sometimes what you can provide in verification,
ID.
a code. It may be 1, 2, 5, 6, 5, 3, something like this, and so on. So you have to say, my name is, you give your name, and you give the code or the password associated to you. Okay? Once you give your name and the password, in your system, we have a database of all people who have the right, for example, to access the system. For you, you said my name is, I don't know, Julien. My name is Julien. Okay, and you use a password. So in fact, in the system, there is one in the table, there is Julien is already stored, and here there will be a password or a code. Okay, so this table is stored or saved in the system, in the control system. So you say, I am Julien, but I'm not sure if really you are Julien. Okay? So the system will get the password, the real password, corresponding to Julien, and it will be compared with the password provided by this user. Okay, there will be a comparison. So this code will be compared to which code? To the code provided by the user. Why? Because he said, I am Julien. He gave his name. He claims his identity. When you claim your identity, directly there will be a pointer which points to the name who has been claimed. Okay? We extract the code and we compare it to the code provided by this user. If the code is the same, here we can say there is a match, and we say it's okay, we grant the access. Okay? So in fact what we are doing, just we verify if this is the right person. That's all. We verify if this is the right person. And even if in our database we have 1 billion persons, the execution of the code is fast. Why? Because once you claim the identity, the name, directly we will look for the name in the table, and we get the code associated to this name, and we compare it with the code provided by the user. If it's okay, we grant the access. So this is a verification. We verify your identity. Now, for identification, how does it work? And for this reason, we say verification is in fact biometric 1-to-1. Okay? 1-to-1, it means I compare one information to one information. And the decision will be yes or no. Don't forget this. It's very important to make the difference between verification and identification. Now, if you take the identification, we have also a database, and we have also some enrolled persons. Okay, and you have one user who wants to use the biometric system. So what will be the step?
There is no need for username.
We will not ask him to provide the name or anything. What we have to do, just we capture biometric data, that's all. This is what we have to do. And now it's up to us to find if this biometric data is saved in our database. So what we have to do, what will be the process? We can compare this data with this one, with this one, and with this one. And we will take the data which is very close to the one captured. And if we find that this one is very close to what we captured, we can say probably this guy is, for example, Julien. And we say we have identified the person because this person didn't claim his or her identity. It's up to us to find him. And here you can see the difference between identification and verification. Verification is easy, especially for programming. It's easy to program. Why? Because just you achieve some comparison. You compare 1 to 1. And here you have to compare 1 to n. In your database you have n codes. So you have to compare with this one, 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 this one. And you can, at the end, you decide probably it will be this information associated to this person. And we say the identity of this person is Julien. Okay? So here, in terms of programming, it's much more complex, especially if your database is huge. Imagine you have a database in which you have 1 billion or 2 billions, persons. Because for the verification, it's direct comparison. And here for identification, you need, of course, to use all the database. So in some applications, you use verification. In some other applications, you need identifications. Give me some applications where we use verification.
Facebook login.
Pardon?
Facebook login.
Facebook login, okay. In Facebook login, you use your username, login, and your password. And Facebook, they have their database, okay? So when you type your login, there will be one pointer who should point to their database with this login, with this username. And after this, based on the password you used, it will be compared. Of course, it's encrypted, but it will be compared to the one stored in the database. And even when you use Windows, access to Windows, sometimes you have to use a password. So it's a verification. How about identification?
Face recognition
Maybe for law enforcement, or maybe in some applications they have to deal with identification. Why? Because maybe they capture someone and he doesn't, provide his identity, and they will just take fingerprint, the face, and they try to find him in the database. Okay, it will be an identification.
In crime investigation?
For crime, yeah, investigations it will be the same. Maybe they can find some fingerprints, but there is no one. Just they found some fingerprints. So what they can do, they compare these fingerprints to their database. Maybe if there is any matching, they can say probably this guy is this one. Okay. So applications are not the same. Very often for commercial applications we use much more verification. Okay, for commercial applications we deal with verification. For law enforcement security purpose, here we can deal much more with identification. Okay. Now, look at this scheme. This is a generic scheme, and always we use a scheme like this. If you understand each part of this block diagram, you will understand everything. So we can just notice you have two parts in this scheme. We can separate like this. You have the first phase called enrollment. What is enrollment? This is the first time you want to use your biometric system, the verification system. You have to give your name, and you have to give maybe a password, or you can give your biometric data. Okay? So here we have to use a sensor, okay, for enrollment. So if the application is connected to fingerprint, in such a case you have to use, of course, fingerprint sensor. Okay. So the first time we capture your fingerprints, and after this we will get one image, and this image should be pre-processed. What does it mean? We pre-process the image. It's just the phase before extracting the features. We discard anything which is not interesting. Yeah, we can remove the noise. We can enhance the quality of the image. We can, So this is the idea of pre-processing. It's all the different algorithms that you use before extracting the features. You try to make the quality of the image better. Remove the noise, remove the noise or denoise your image, or make it easy to process. This is the pre-processing. So once you remove all the information that are not very interesting for you, here you will obtain one image, if it's for fingerprint. And from this image, you extract features. Probably, I think in the next, it will be like this. So this one is the original image. And you can see this one, which has been pre-processed, where we highlight all the different lines clearly. Why? Because once we have an image like this, it will be easy for us now to extract some the minutiae. Okay? original image, this is the input image, pre-processed image, and after this you obtain the features. You extract your features. Once you extract the features, you will save this in a template. It will be a signature. We call it template. We can call it a signature. It will be stored in a vector. And after this, it will be stored in database. So if this person, as we said, is called Julien, since we are in the enrollment phase, here in the database, there will be Julien, and we store here the template. Okay? Always you have the name and the template. So this is the enrollment phase. That's why I said I split the block diagram into two parts. Enrollment, okay, and now we have the test phase. Okay, imagine we deal with verification, not with identification, just verification. So the person wants to access to the system. So we will use exactly the same sensor. Okay, we use the same sensor. If you use a fingerprint sensor, so you will capture an image. It will be a second image, not as the first one that you saved. Okay? It will be a second image. And what will be the next step?
Also pre-processing
and we do exactly, we run the same algorithms as we did before. We run the first algorithm to pre-process the image, then we extract features, then we extract a verification vector. Okay, so we extract one vector. So it will be the output, because here you can notice we have two outputs. You see, the first output, it was basically to create a template or to create signature. The second output is in fact in the test phase, and it contains your features here in this vector. And then what we have to do, just we compare, okay? We compare the data stored in database and the data extracted from this image. And at the end, we take a decision if there is a matching or not. The output will be yes or no. Do you agree? We are in the phase of verification. So verification, the output will be yes or no. This is the decision. You are the person, the claimed person, or you are not. And we can notice that each time we share the same systems, you know, in terms of processing. For pre-processing, for feature extraction, we share the same blocks. And the output at the end will be yes or no. Okay? If your system is a face recognition, you can just notice that it's exactly the same scheme. You take any biometric system for security, always the same scheme. Capture, you have the enrollment, you have to use a sensor. Which sensor we can use here? We can use a camera, and after this we pre-process the image and we extract just the features. We can see here the features in blue. Okay? So during the enrollment phase, you extract one vector as a template and you store it in database. Now, in the test phase, you capture once again face image, you pre-process it using exactly the same algorithm as what you used before, and you extract other features and you will obtain another vector. And this vector will be compared to the one stored in database to check if there is matching or not. And the result will be yes or no. Okay? So this is the verification phase. So remember last time what I said? I said when you deal with biometric applications, you can be much more involved in electronics. Sometimes you can be involved in image processing and signal processing, or maybe you can be involved in computer science. So people involved in electronics deal basically with this part. People involved in signal and image processing deal with this part. And computer science, you should deal with all these parts, but you don't need to access to all the details in terms of programming. Okay, someone from the computer science should connect the different information, okay, like this, and he will deal with the database and also the decision systems, how to take a decision. As we said, to take a decision, you can, the simple method is to compare one-to-one. But in some applications, especially for identification, we use classification method. So classification method, you can use it basically for in identification cases. And in identification, how it works, you can just notice that you keep exactly the same scheme. You don't have to change anything between verification and identification. You keep the same scheme. The difference is that, let me please just, I will remove this. Okay, good. So for the identification, sorry, here it's okay. No. So for the identification, just we capture the face of someone. We process the image, or pre-process, we extract the features, and we will get, of course, a vector of features. This vector of features should be compared to all the features stored in database. If the database is small, you can compare one by one. And at the end, what will be the output? No, in identification. Someone, the name of someone. This is an identification. This will be the final decision. Okay, in identification, the output here shouldn't be yes or no. It should be the name of someone, because we identify someone. And here, in terms of programming, you have to compare this vector provided by, after the feature extraction, you have to compare it to the whole information stored in database. As I said, if your database is small, you can compare one by one. But if the database is huge, here you have to develop a strategy, okay, to find or to identify the person. And you can use some classification methods. Okay, you can use some classification methods to find out the identity of the person. Okay, so the scheme will never change. It's always the same. Between the identification and verification, the schemes are close. Because you have here the step 1, 2, 3. In terms of processing, it's almost the same. So it should be like this. Okay? Identification is the same. The only difference is, the difference is at the beginning, because for the verification, you have to claim your identity. It means when you arrive at the level of database, we don't have to compare your information with all the provided information here. Directly we point to your name, we extract the signature, and we compare. For identification, we have to deal with all the database. So in terms of programming, it's not the same. It's much more complex when you deal with identification than when you deal with verification. It's always the same, always the case. Very complex with identification. Of course, when you have a small database of 10 persons, it shouldn't be a problem. 10 persons, you can compare. It will be quick, fast. But if you have billions of data, here it will be complex. And for classification, you will take classes and labs on classification methods. You will see there are a lot of approaches of classification. Some of them called k-means methods. Some of them Bayesian approaches. You can use neural networks. You can use SVD. So there are many approaches. That's why I give you all these names. You can just be ready, because you need them. Different approaches of classifications. And you have to practice. Okay, you have to practice, and you should be very comfortable in classification, because always you need it. Yes, someone has a question who wanted to ask. What are? I have already answered. Okay, good. So you have to practice. You should be very comfortable in these different methods of classification. K-means, Bayesian, neural networks, SVD. Yes? This one, Bayesian. Bayesian. It's from Bayes, like this. It's connected to probabilities, It's the name of someone. Of course, yeah. That's why we call Bayesian methods, Bayesian approaches, and so on. So I advise you to practice. You can use MATLAB or other tools, because in some MATLAB toolboxes they integrate these tools. But you will take some classes, okay, about different approaches, and after this you will practice. So why it's very important? It's very important because if you take any biometric scheme, you need this block to take the decisions. So if you are comfortable in extracting, in capturing data using some sensors, if you are comfortable in extracting features, if you are comfortable in using databases, but you have a problem with classifications, here your system will not work. Okay? So, if you look at this scheme, and if we ask you to develop a biometric system, first, you have to know how to capture data. It means which sensor I have to use. The sensor that you will use is supposed to provide you an image or a signal. This is the first point, capturing data. The second point, you have to practice, you know, in terms of image processing. Image or signal processing. Okay, which includes, of course, feature extraction. It's difficult to write, but feature, I cannot write extraction. Three, you should be comfortable with databases. Last year you took some classes on databases. Just yeah. Pardon? It was introduction to databases. Have you practiced a lot, little? You didn't practice? So I think it's very, very important to take some labs. There will be some labs this year. You need to practice in terms of databases. And number 4, you should be able, you have to know how to compare signals or how to compare data or how to classify data. Okay? Why? Because in biometrics you need all these different parts. Capture, processing, database, classification. Okay? So here in database you can, and probably you will take some classes, you know, about MySQL, things like that, to know how to set up, you know, the databases. It's very important. This one is image processing. So this one is computer science. This one image processing. This one may be electronics, but if you use some simple devices, it will be really easy. Even if you are not expert in electronics, you can capture data. For example, from the camera, from the fingerprint devices. It's not complicated. And you will take a lab. I showed to you last time the fingerprint. You will use it to capture, to connect it to different applications. And even with Emanuela Marasco, normally you will see some applications. Okay, so capturing data, image processing, data processing, and the comparison and decision. Here, classification. And here, as I said, think about the different methods or approaches of classifications. K-means, neural network, Bayesian, SVD. There will be some labs. Okay, you will take some labs. For this one, you will take some labs on databases, but image processing, you will always work with image processing. Okay, so if you you understand how this first point works, how this one works, how this one works, this one works, you will be able to develop your own application. Even as I said last time, you are not supposed to be expert in everything. So you can maybe concentrate on one part of these different parts. For me, someone who is good in capturing data, image processing, databases, and classification, it's okay. You can do anything you want. Any application can be developed. Any application. Just think about the application, and you have the answer here. Tell me, imagine one application. Very simple, this one. Very simple. I have a question. Classification is used in order to speed up the processing. In fact, the classification, certainly when you use classification, you will get a result quickly, it's for sure. In fact, the classification should be used to avoid comparing the captured data with the data who are stored in database one by one. As I said, if in the database you have 1 billion signatures and you capture from a user one signature, do you imagine if you compare one by one, it will take time. So if you use some specific classification approaches, you will get the result quickly. Okay? So I have, Sayed said, an application recognize people in image on social network. Okay. Yeah, it may be an application like this, but it will be just maybe face analysis, except if you want to use other features. Always you have to think about something. At the beginning, what should you capture as data? So this is the first information. What do you need as biometric data? Okay, so you have to reply. If you say fingerprint, this is biometric data. If you say face, this is biometric data. If you say typing on the keyboard, it's also biometric data. And the result will be one signal or one image. Okay, each time you decide about the modality you want to use, the output here will be signal or image. But once you have the signal or the image, it's not finished. This is just the beginning. This is just the beginning. So you have to extract some features. But before extracting features, just to try to make your signal or image prepared to feature extraction. So try to remove anything which is not important for your application. We call this pre-processing. Pre-processing. Okay, so you pre-process your image and you extract features and you store in the database. Okay, that's why it's important to know how to use databases. After this, when you want to compare, if it's a small database, you can compare one by one. If it's a huge database, it's better to use a classification approach. As I said, there are many approaches that can be used for classification. You will take some labs and at least to see how it works. Okay, you will see theory and practice. But what is important for you, at least, to have this general scheme. You say, okay, I know exactly what I want. Or if, for example, we ask you to develop an application, directly you can see these 4 blocks. Data capture, image processing, database, and decision, the decision tool. And this decision can be classification, can be comparison, can be anything. Okay? Just 4 blocks. So imagine, as I said last time, you are a project manager and they ask you to develop an application. Okay? So you are a project manager and you have to hire persons like last time. You to use biometric system, you will hire. What are the profiles? Remind me. You are project manager. Okay, project manager, and the purpose is to develop an application, biometric application, and you want to create a team. You work with your team. The first one you will hire maybe is someone from the electronics. Okay? The second one you will hire is an engineer in the data processing. And the third one, it will be an engineer, software engineer. It will be a software engineer. It means his profile should be computer science. Okay? So this is your team. You know what you need, and now you have to know with which person you have to work. And for this guy, you will give him some tasks. Explain to him what will be the input, and just explain to him, I need this output. Okay? For the second one, you will tell him, I will give you as an input, tell me what will be, is the output provided by the first guy. Okay, this output will be the input And this one will provide also an output. And here, project manager will discuss with the software engineer to tell him what he should do, how we want to create this software application. Why? Because the software engineer can access to all different information. So we will ask him, create a database, do this, do this, do this, do this, and he should run some classification or decision modules. In fact, classifications, even for someone who, from the data processing, can work on classification, but also software engineer can work on classifications. Okay, so since you are project manager, you know the main scheme of biometric application, so you can ensure coordination between different persons. Okay. So it's not really very complicated because, as I said, you have 1, 2, 3, and 4. Okay, and in each phase, you need to know something. Okay, do you have questions? Do you agree if you master all these parts, you will be able to develop a useful application? And if you cannot do it alone, you can work on group, team. But the project manager should decide, say, okay, the input should be this thing, the output should be this thing. And he makes coordination between different persons. Why? Because the project manager will have feedback from electronics guy, feedback from the person, the software engineer, feedback for data processor, and so on. Okay, and based on the feedbacks, so he can adjust all the project and manage the project. Okay, so if you keep this scheme, if you memorize this this one, okay, this general scheme, it will be easy for you to understand many things. What I'm doing, I will just want to remove, delete. Okay, this is what I said. You have to memorize a scheme like this, and you decide if you want to work in this part or if you want to work in this part, or if, of course, if you want to work in this part. When you finish your master and you start looking for a job, in the profile they will say, we are looking for someone. You will not find in the profile someone who is able to develop a global biometric application. I don't believe in this. You will say, you will find in the profile someone who has experience in biometrics in general, okay, and who should work in some specific parts of the scheme, maybe data processing, maybe they say, we are looking someone to deal with databases and classifications in biometric systems and something like this. They will not ask you to do everything. If you are a software engineer, They will ask you to integrate some solutions. Integration. Think integration. Okay? Do you have questions? No question? Is it okay? Yes? It's okay? Good. So I think we have another class this week, Wednesday. Maybe Wednesday. Yeah. Yes. So as an advice, start looking for classification methods, different approaches, and have a look on databases before doing because you will take some labs, but start from now to have an idea about different databases and MySQL and classification approaches. Okay? Good. So thank you and see you soon. Bye. Voilà.